Okay, welcome to Kajal Kasu Physics Academy. Today we study the part 3 of the projectile motions. Okay, already we have read that if we project this, then we find the time period and also we find the range. Now, if we project the particle making an angle theta from here, then the trajectory of the particle just like this here, a complete projectile. Now particle again falls in the ground with another projectile. Okay, that is the V, and particle falls here. So what is the total range? These are, that means these are plus x. This is the total range of the projectile. So r plus x is the range of the projectile. This r is nothing but this r is nothing but the range of this projectile at a height. Suppose it is h. Suppose it is h. How can you find the time of flight? Very interesting case to find the time of flight from the vertical motions. In vertical motions, initial velocity u sine theta, and when the particle strikes here, the vertical velocity vy is nothing but root over u square plus 2gh, u square plus 2j, that is u square sine square theta plus 2gh. Okay, here g is negative, h is negative, so minus minus plus, and u square sine square theta, so we get the vy, that is the striking velocity of the particle, and time of flight t equals to this vy and this uy, initial velocity along y-axis vy plus uy divided by 2 divided by g, that is the time of flight of the particle. That means particle takes time to move from A to C. A to C. That is the time of flight. And it is coming from the vertical motion theorem. Okay? Vertical motion. V square equals to u square plus 2gh, or v square equals to u square minus 2j, as you like. You can apply this. And here g is negative, h is negative, and u square. So you get the time, and now you get the range. Range means u cos theta, that is the horizontal velocity ux. So ux into total time of flight. Ux into total time of flight. So range will be u cos theta into t, that is vy plus uy by g. Vy means this, uy means u sin theta divided by g. Okay, that is the range of the projectile. This kind of projectile, whenever you throw the projectile making an angle theta at a certain height, you get the result range very easily. Okay, from this method. From this method, you can easily find, or you can find the striking velocity. Striking velocity means ux, because ux never change because no acceleration is present. So it is ux and it is vy. So striking velocity v equals to root over ux square plus vx square. Or striking angle, again alpha. Alpha means tan alpha. Tan alpha equals to vy by vx. Okay, you get this result. So striking angle, striking velocity at the ground, and time of flight of the projectile, that is complete time of flight of the projectile, easily you get from the vertical motion. Okay, that is the second case. And now the third case, from a height. Already we have read in the part 2 the first case, and now it is second case, and now third case. Third case means in this way, we throw the stone aiming towards certain point on the ground. Suppose here A present here at a height h, and B stand on the ground. A throw the stone aiming towards B. That means aiming towards B. That's mean we get the angle. Because we know the height, we know the displacement, we know the distance of B from this wall. So if we know h, if we know h and this x, then is this theta? This will be theta. So tan theta equal to h by, suppose it is x naught. But projectile falls not at B. Projectile falls at C. Okay. So there must be some shortest distance, because B stand here, A aiming towards B, throw the stone, but stone falls at the point C. Then what is the short? BC is the short. BC is the short, because projectile could not hit the B. Projectile lands on the C. So there is a gap between the landing of the projectile and aiming point. So this is the aiming point and it is the landing point. So there must be some gap, and we call it BC as del x. And how can you find this del x? Easily you can find. Again you have to find the time of flight. Here time of flight, suppose initial velocity u, and this u cos theta, and this is u sin theta. Okay. Again, when the projectile strike here, must be some vertical velocity. When the projectile strike here, so when the projectile strike here, u, and projectile land here, so there must be some vertical velocity, and horizontal velocity is the same, u cos theta. What is the vertical velocity? Again, Vy equals to root over u square sin square theta plus 2gh. We get from vertical motion, okay, v square equals to u square plus 2gh. So we get Vy, we know u Vx, we know Vx, and we get Vy. So we get the time of flight, that is Vy minus uy by g. That is the formula. Okay, Vy minus uy by g. This is the formula. Okay, time of flight. Very shortcut for JEE. So I just give you this result: Vy minus uy by g, and whenever you throw the stone in upward direction, Vy plus uy by g. Okay. So that is the formula: Vy minus uy by g. You get the time of flight, and then you get then you can calculate A, B, C, D. Then you can calculate the DC. This distance you can calculate, because DC is the range. So DC is the range here, and range is nothing but DC is nothing but ux into t. So u cos theta into t. T means this is Vy minus uy by g, and you get the result DC. You get the distance DC, and you know BD. Then the shortest distance, that is the short distance, the gap between the landing point and the aiming point, that is BC. So BC equals to BD minus DC. BC equals to BD minus DC. That is the question asked in JEE Main and Advanced. Okay, BC equals to BD minus DC. This type of question generally you can see in different type of books. Okay, and how can you get the theta? Well, sometimes question arise, how can you get theta? Because tan theta equals to h by BD. Because tan theta equals to h by BD. That's the very interesting formula. Tan theta perpendicular by base, so you get the theta. Okay, because particle is thrown aiming towards B. That means they wants to the question setter wants to tell you that this is the direction. This is the direction. Okay, of aiming towards B means this is the direction of the U, and you just find the theta and making an angle theta with the horizontal. If it it is theta, then it is then tan theta goes to perpendicular like this, and time of flight, and that is the range, and that is the gap, and that is the Vx and Vy. Again you can find the striking angle by tan alpha equals to Vy by Vx. Again you can also find the tan alpha. Tan alpha means striking angle. That's angle tan alpha. You can find the tan alpha by Vy by Vx. Okay? Striking angle Vy by Vx. Okay, clear? Okay. Now, we already know that three type of projectile from a height. We already come to know that three type of projectile takes place. Number 1, number 2, and number 3. And from ground to ground. And now we just see some cases around this type of projectile. Some cases means some type of touching concept. Just like touching. Touching means whenever particle is thrown, okay, this is the trajectory. If you just see height, suppose HH, if you can see that these 2 points are in the same height, and the projectile touching this point and again touching this point and lands at here. So H is the height of the particle, and it is same for the 2 times. That means after t1 second and again after t2 second. Height is the same. Height is same. And suppose this angle theta, then it is u cos theta and u sin theta. U cos theta and u sin theta. You can find the relations between h, t1, t2. You can easily find the relation between h, t1 and t2. First time, this is the first time, if we use the symmetry, then if it is t1, then this should be t1. First, from symmetry. We get it from symmetry. Second concept we get, t1 plus t2 is nothing but total time of flight. Very interesting. Total time of flight. Because t1, this t1 is this. So t2 plus t1, that means total time of flight to move from O to suppose P. So t1 plus t2 is t, total time of flight. We apply some symmetry concept because the curve is parabola and g is constant, means acceleration constant. So you can apply the symmetry concept easily. Okay, and no air drag, mainly no air drag. I just tease you without taking any air drag. But in the part 5, part 6, when I just give you video of part 6 and part 7 or part 8, part 9, then I will take the air drag, and in that time you can see something new figure of the projectile. Now t1 plus t2 equal to t, and at the first video I have given you, suppose this is the maximum height. Suppose this is maximum height, and I will give you t square equal to 8h by g. That is TOP, and suppose TAB means 8 into h minus h by g, because maximum height for C to D, maximum height for A to B is this, and this is nothing but h minus h. So 8h by g, you can apply this, you can apply this, you can apply this, you can apply this symmetry also. Or number 1, 2, 3, 4 in your hands already present. Now the 5 number concept. H is same. Now you can apply this. H is same. What can you do with H is same? H equals to u sin theta into t1 minus half g t1 square. Okay. Again, up to t2 second, H is same. So again H equals to u sin theta into T2 minus half g T2 square. Okay, is equal to ut plus half t square. Very easy equations. Now equating this to h. Okay, so this equal to this. So u sin theta into T1 minus half g T1 square equals to u sin theta 2 into T2 minus half g T2 square. Now u sin theta into T1 minus T2 or g by 2 into T1 square minus T2 square. T2 square. Now we get a square minus b square, a plus b into a minus b cancel. So u sin theta equal to g to T1 plus T2, okay, by 2. A minus b, a plus b into a minus b, okay. So you get the result u sin theta equal to g into T1 plus T2. This is, okay. Or now putting this u sin theta in one of the equation. Now putting this u sin theta in one of the equations, what you get? H equal to u sin theta means g by 2 T1 plus T2 into T1 minus half g T1 square. Now you get half g T1 square plus g T1 T2 by 2 minus half g T1 square. Cancel. So H equal to g T1 T2 by 2. Most fantastic, very, very important, VBI. Okay, just you have to memorize this formula. H equal to g T1 T2 by 2. Okay, that is one of the touching concept. That means particle touches the two pillars of the same height but at a certain distance. Particle touches the two pillars placed at a certain distance. Like triangle touching, particle can touches the triangle. That means if you throw the particle u, making an angle theta, okay, then particle touching the triangular base. This may be possible. Or hexagonal touching. Hexagonal touching also possible. Hexagonal touching. Hexagonal touching means hexagon. Suppose it is a hexagon. Hexagon, regular hexagon means suppose it is a regular hexagon. Okay. If you throw the stone here, just in this way, then particle touching this, touching this, touching this, touching this, land here. Okay, hexagonal touching concept. Very interesting. If the side length A, all the angles, this is the coordinate, this point and this point, suppose it is P and it is Q, okay, or it is A, okay, you can find the coordinate of the P and Q, coordinate of the point, this is the Y and this is the X. If it is 120 degree, then it is 60 degree. So Q coordinate is A cos 60. If you take origin, then minus A cos 60. Okay, this is X and Y means A sin 60. Coordinates of the Q. Coordinates of the Q. Coordinate of P 0. Suppose you take this is origin 0, 0, 0. You take this is origin. Then this is the coordinate of the Q. Minus A cos 60 or A sin 60. And this is the coordinate 0, this length. What is the length of this? In regular hexagon, you can easily find regular hexagon. In regular hexagon, you can easily find this length because this is 120 degree. So this is 630 and this is 30 A. So this is A cos 30, A cos 30. So coordinates of P 0 comma y 2a cos 30. So you get the coordinates of P and you get the coordinates of Q. Or an interesting fact, very interesting fact, the distance of the throwing of the particle, suppose from here A. So the distance of A to this origin, okay, O, and this distance must be equal because it is symmetry, because regular hexagon. So again you can apply symmetry. So this distance and this distance are same. AO, suppose you can take AO, and if it is O, Q, P, R, S, T, or this is C, then DC equals to AO. It is coming from symmetry. Okay, just to learn this theory. Okay, after that you can easily crack the J-man and J advanced problem. No problem, okay, arise in your mind or in your any time of solving the problem, okay, or in your concept level. Q equals, so why we find the coordinates of P and Q? Because we know the trajectory of the particle. How can we know the trajectory of the particle? We know the trajectory of the particle y equals to x tan theta into 1 minus x by r. And here y equals to for P and Q, both points, both P and Q satisfy the equation. So you can put the value of coordinates of Q, x here and y here, okay, and r means A plus this, r means A plus twice of AO. This is the R. AO must be given in your question. Okay, no problem, no tension. So you can put R, x and y coordinate for P, one time for Q and another time for Q. Then you get the two equations. Simultaneously you get the two equations of x and y and solve for x and y. Okay, and you get the result theta, A, anything. So this is the hexagonal technique. Very, very interesting problem. Just I give you some concept about hexagon and slightly you know the geometry. Okay, now this is the time for ending. Okay, and we have already passed our time. In the next video I will start from this touching concept, and you must subscribe my channel to inspire me. Okay, and if you have any doubt in projectile, okay, after part 6, 7, 8, 9, 10, I just feel that maybe parts 10 up to 10 projectile may continue. Okay, part 10 तक कंटिन्यू हो सकता है, तो ठीक है, उसका बाद हम डाउन देख लेंगे. तो गुड नाइट.